Welcome to this channel, and in this video we're going to be looking at how to determine the point of inflection of a curve, right? And if you've been consistent with this series on the theoretical application of differentiation, you'll see that we looked at different things. Look at how to determine maximum and minimum points, right? And that leads us to what the point of inflection is all about. I'm not sketching, and this is just a sketch. So now, from the previous videos we said that for a function to attain a maximum point, what happens? The second derivative should be what? Less than 0, and for it to attain a minimum point, the second derivative should be greater than 0, right? So what's this point of inflection all about? The point of inflection is a point on a curve where what happens, concavity changes from what? Concave up to concave down, or maybe from concave down to concave up, vice versa, right? So what's that point? So let's bring these two together. If you have a curve that has the maximum and then something like this, what is that point? That's first of all the function was going concave up, and then the point of transition to what? Concave down. That's a change in concavity. So it simply occurs when the second derivative of x is 0, and then this is only valid if there is a sign change, right? Sign change at that point greater than that value and less than that value. Let me explain further with an example. So let's say you are given this question in the exam, and it says f of x is equal to x squared negative 3x, and you ask determine the point of inflections, or the points of inflection of the curve x squared negative 3x. So what do? Get the first derivative. The first derivative of this is going to be what? Sorry, this is x cubed, not x squared. Sorry. If you get the first derivative of x cubed, it's going to be what? 3x squared, right? Negative 3. Do you understand? And then if you get the second derivative, we differentiate 3x squared, 2 comes down, right? So it's going to be 6x. And then negative 3 is a constant, so it's going to give us 0, right? So this is the second derivative. So what's the next step? Equate this second derivative to what? 0. That means that 6x is equal to 0. And when you divide through by 6, that means it is what? It is 0. So we are not sure yet too, right? It's not a sure thing that the point of inflection occurs at x equal to 0. You have to test for a sign change. Now the second derivative, we got it as 6x, and our proposed point of inflection is x equal to 0. But now you now have to test any value greater than 0. You can use 1, you can use 2. Are you following? If you use 1, 6 into that is, you are not substituting 1 into the second derivative function, it's going to give you what? 6. Then choose any value less than 0, like minus 1, minus 2. 6 into minus 2 is what? Minus 12. So when you see that, when you substitute a value greater than that value that you propose to be the point of inflection, we substituted a value greater than 0, right? And we got a positive number. We substituted something less than 0 and we got a negative number. So whenever, it does not have to follow that order, but when you substitute something greater and something less and the signs are not the same, if the signs are the same, that means that's not a point of inflection, right? But if the signs are different, that means there's a point of inflection. So those are the two conditions. First of all, equate the second derivative to 0, and then ensure that there's a sign change. You get? So let's have that. So in this case, we substituted x as 0. So what is the output? At x equal to 0, what's the output of this function? Remember that the original function is f of x equal to what? X cubed minus 3x. And if you substitute 0 in this function, it's still going to be what? 0. And then to visualize this, because I want you to understand, right? If we visualize x squared negative 3x on a graph, this is how it's going to look like. Sorry, not x squared, x cubed. X cubed. X cubed minus 3x on a graph. This is how it looks like. So what do you notice here? At this, as we are just moving, concave up, concave up, concave up. So it's at 0, 0 that there was now a transition towards a concave down. Do you understand? Do you understand? So that is it. So basically, point of inflection occurs at x equals to 0, which is basically this green line now. Do you understand? Okay, let's take more questions so that you get along with all of this. So the second question says f of x equal to x cubed negative 6x squared positive 9x and positive 5. And please, it's important to note that quadratic functions do not have points of inflection. Why? Because, for example, if you have a quadratic curve now, before we answer this, for example, if it's like this now, there's no change in concavity. This is a concave down scenario. So there's no point where there's maybe a transition to a concave down, which occurs mostly for the cubic functions. So in this case, what are we going to have? Second derivative. Let's first of all get the first derivative. First derivative of this is what? 3x squared negative 12x positive 9. Because 2 comes and becomes 6 times 2. Derivative of 9x. Derivative of a constant is 0. So if we now differentiate again, what's it going to be? 2 comes down, right? So it becomes 6x and then negative 12, right? And then differential of positive 9 is 0. So this is the second derivative. So what do you now do next? Equate the second derivative towards 0. Add 12 to both sides is 6x. Negative 12 plus 12 is equal to 0 plus 12, right? And that's 6x equal to 12. And dividing through by 6, what are you going to get? X equal to 2. So do not rush to say, 2 is that it gives us the point of inflection. Test for a sign change. Remember that the second derivative is what? 6x minus 12. So when you substitute a value greater than 2, for example 3, so the second derivative at x equals to 3, that's 6 into 3 minus 12, and that's 18 minus 12, which is equal to what? 6. And then second derivative at a value maybe less than 2, you can use like 1. If you use 0, 0 is less than 2, right? So 6 into 0 minus 12 is what? Minus 6. So you can see that the signs are different when you tested values greater and values less. So since there is a sign change, we can confidently say that x equals to 2 gives us the point of inflection. And since the original curve was given as f of x equals to x cubed negative 6x squared plus 9x plus 5, you substitute anywhere you see x, substitute 2. That will be 2 cubed minus 6 into 2 squared plus 9 into 2 plus 5. Right? 2 cubed is what? 8 minus 2 squared is what? 4. 4 times 6 is 24 plus 9 times 2 is what? 18 plus 5. 8 negative 24 is negative 16 plus 18, right? Plus 5. So with that, negative 16 plus 18 is what? 2, and 2 plus 5 is what? 7. So basically we can see that the point of inflection is 2,7 because we got this point of this x value by equating the second derivative to 0 and then getting the output from the original function. And if we should show this visually, what is it going to be? Right, that's x cubed negative 6x squared, that's coming up, negative 6x squared positive 9x positive 5, and that is this. You can see it's over here, it's a different curve now. So, and what did we say is the point of inflection? It occurred at what? X equal to 2. So at this point, there's a change in concavity, right? The change in concavity from concave up to what? A concave down, right? The rate of change of the slope at this point is 0, right? Because no, second derivative is the rate of change of the first derivative, right? So this is the point of inflection. Right, so with what I have been explaining since, please do well to pause the video and attempt this question. If you are given f of x equals to negative 2x cubed plus 12x squared negative 5, and you are asked in the exam to determine the point of inflection of this curve, if there is any. So, right, so pause the video and attempt. Have you paused it? Okay, so first derivative, you differentiate this, the 3 comes down, it becomes negative 6x squared plus negative 2 times 3 is negative 6, and then positive 2 comes down, it becomes 24x, right? And differential of a constant is what? 0. Then we get the second derivative, and then when 2 comes down, it becomes negative 12x, right? And then derivative of 24x is positive 24, right? So equate the second derivative to 0, and that'll be negative 12x positive 24 equals 0. So subtracting 24, that's going to be negative 12x is equal to negative 24, right? And then dividing through by negative 12, we'll have that x is equal to 2. And then we carry out the test, right? We have to test. So if we carry out the test on second derivative, which is negative 12x plus 24, if we substitute any value greater than 2, because when we equated to 0, you got to, if you use like 3 or 4, any number greater than 2, that'll be minus 12 into 3 plus 24. That'll be minus 36 plus 24, which is what? Minus 12. Use any value less than 2. Let's even use minus 5. So what's it going to be? Second derivative of negative 5 is negative 12 into negative 5 plus 24, which is going to be 60 plus 24, which is positive. So you can see that when we imputed a value less greater than 0, which was 3, we had minus 12, and when we imputed a value less than 2, we had 84. And since they have different signs, we could say yes, this is a point of inflection. So we can now go ahead to substitute in the original function, which is negative 2x cubed, negative 2x cubed, positive 12x squared, negative 5. And then on substitution, that will be negative 2 into 2 to the power 3 plus 12 into 2 squared, negative 5. And that will be negative 2 into 8 plus 12 into 4, negative 5. And negative 2 into 8 is what? Negative 16, and then positive 48, and then negative 5. 16, negative 16 plus 48 is the same thing as 48 minus 16. And what's 48 minus 16? It's what? 32, right? So 32 minus 5 is what? 27. So basically, we could say that the point of inflection is 2, 27. 2, 27. And then if I should show you this graphically, this is not the curve, right? Let me bring out the curve right now so that you could see clearly. That's negative 2x cubed, negative 2x cubed, and then positive 12x squared, positive 12x squared, and then negative 5. Whoa, this is large. Okay, let me bring this. Wow, this is big. So this is the curve. This is the entire curve right now. I want you to see the point of inflection clearly, right? And what did we get? We said that the point of inflection occurs at what? 2, 27, right? And then over here, can you see it? That's the point of inflection where the curve is transitioning from a concave down to a concave up situation. Even in the case of y equal to negative x cubed, in the case of y equal to negative x cubed, what we're having there is this. Let me remove this graph. So you get my point, right? So that's it. In the case of y equals negative x cubed, this is what we're having. At what point does it transition from concave up to concave down? There's a line there, x equal to what? 0, right? So that's basically what it is. So once you are given a question, what do? Get the second derivative. And after that, what next? You equate the second derivative to 0, carry out the test to know whether there is a sign change, and then if there's a sign change, that's perfect. Substitute that value into the original function to get the y output, and that's the point of inflection. If there is no sign change, then you're gonna see that the curve has no point of inflection, right? Just like I said in the case of quadratic curves. If I should give an example now, f of x equal to x squared negative 6x plus 8, and I ask you what's the point of inflection. If you differentiate this the first time, it's going to give you what? 2x minus 6. Are you following? You differentiate it again, it's going to give you what? 2x to the power 0, right, which is still 2. So even though we substitute a positive number, are you following? You see that there is no sign change. Even though we substitute 1 as x, 2 into 1 to the power 0 is what? 2. 2 into minus 5 to the power 0 is still 2. No sign change. So there's no point of inflection. Do you understand? Thank you so much for watching this video, and I believe you've learned a lot. And are there any question asked or brought up to you asking you to determine point of inflection, you should answer it without stress, right? Thanks once again. Do well to subscribe to this channel if you've not, like and share this video so that this video will get to others out there who need it, right? Thanks once again and have a nice day.